Students, welcome to my another exam success series video. That is a master class. Today's topic we will be discussing about microcontroller application and programming. There will be two parts in this. Today we'll be discussing about the first part. So microcontroller application and programming. As you can see down below in the picture, there is a microcontroller. What are the other things which are there inside? That is CPU, ROM, IO, DAC, that is digital to analog converters, clock, and ADC, all these things. On the right-hand side, different type of chips you can see, that is ICs, which are nothing but microcontrollers. Introduction to microcontrollers. So what is microcontroller? A microcontroller is a compact integrated circuit, right, designed to govern a specific operation in an embedded system. So please remember, we are studying about embedded system board. On an embedded system board, we have a microcontroller. A typical microcontroller includes a processor, memory, input, output, I/O peripherals on a single chip. That is, inside a black color single chip, you have all these peripherals inside. On the bottom side, you can see the block diagram, very simple block diagram. That is CPU, bus control, I/O pins, ports, RAM, ROM, and timer. That is oscillator. Everything will be present on, not the exactly oscillator. Oscillator will be outside, but all these timers will be present on inside the chip. Next slide, we will evolution of microcontroller. We have to understand what is microcontroller. In 1971, the first 4-bit, that is, we call it as a 4-bit era. A 4-bit microcontroller was introduced, that is TMS 1000, the Bytex instrument. In 1970-80, that is in between that particular 8-bit of era was introduced. That is 8048 in 1976, and legendary 805, which we study today also. That is 8051. That has come in 1980. 1990, the development happened in flash, specialized in memories. Introduction of flash memory allowed for electrical engineer to programming facility, faster development, like PIC controllers, PIC 16C84 in 1993, very famous and old controller. Present day, we all have 32-bit or beyond compute with microcontrollers. We call it as a modern microcontrollers are highly integrated, featuring 32-bit cores like like ARM and Cortex-M microcontroller. Low power consumption and specialized peripheral for IoT and artificial intelligence. That is especially example you can give is STM32 and ESP32. All right, so we'll go to the next slide. Application of embedded system, where we use this. We use it in automotive, home appliances, industrial automation, IoT wearables, office equipment. On the right-hand side chart, you can see, like say all heating system, centralized heating system, ATM, fitness trackers, telecommunication, automobiles, and other things, consumer electronics, medical devices. As you can see, everywhere it is used. So no sector or place or equipment is left where we don't use embedded system or microcontroller. All right, so we'll go for the next part, which is very important. That is, you should know the difference between microprocessor and microcontrollers, because we are discussing about microcontrollers, but you should be able, this is very important, you should be knowing about what is the difference between microcontroller and microprocessors. So microprocessor is an off-chip, that is a simple chip. Off-chip means, apart from that, other things will be outside, whereas microcontroller is one chip, on-chip device, that is only on one chip, everything is present, RAM, ROM, IO, port, CPU, and everything will be present in that. Microprocessor are general purpose, and whereas microcontroller a specific purpose unit, right? It will be given a specific task, or where the specific task is there, it will be used there. Microcontroller. High cost, that is microprocessors. Low cost, that is microcontrollers. So on high power consumption and use on a high scale application in the case of a microprocessor. In the case of a microcontroller, low power consumption used for low scale application. So this difference you have to compulsory remember. Now we'll have a small summary of common families. That is, what are the different families present in the microcontrollers. The first one is ARM Cortex-M. That is 32-bit microcontroller. It belongs to architecture, that is a RISC architecture, we call it as, and it is used for general purpose IoT industrial automation. Whereas second family is PIC. It comes in 8, 16, and 32-bit. It belongs to architecture RISC as well as MIPS, that is common. Consumer, automotive, and general, where we use it. Consumer, automotive, and general purpose. Next is AVR, that comes in 8 and 32-bit RISC, right? The very popular board, that is Arduino board, we can see that IC belongs to the AVR family. right? And architecture is RISC controller. Then what we study in our colleges and universities, that is in the engineering subject, that is 8051, 8-bit computer, CISC, that is CISC, Industrial Legacy System. It is, we call it as an Industrial Legacy System for study purpose and for this thing. So since it is only 8-bit. Then came the MSP 430, it is a 16-bit. It belongs to architecture RISC and low power medical sensing. And finally, for IoT and other Wi-Fi devices, we use ESP32, that is 32-bit RISC architecture. Right. So this will give you a little idea about what are the different families of your microcontroller. Now we'll study one by one. That is 8051 microcontroller architecture. 805 microcontroller, that is very common. We study in our this thing, is designed by Intel in 1981. It is an 8-bit microcontroller. It is built with 40 pins. Please remember it. That particular chip or IC will have 40 pins. Dual line package. That means one side 20 and one side 20. 4 kilobytes of ROM storage and 128 byte of RAM storage. Second is 16-bit timer. You have two 16-bit timers. It will be consisting of, it consists of our 4 parallel 8-bit ports, right, which are programmable as well as addressable as per the requirement. And on-chip crystal oscillator is integrated in the microcontroller, having crystal frequency of 12 megahertz. That is the clock speed, or we call it as a 12 megahertz. On the bottom side, you can see this is the block diagram. Just in the beginning, we have seen the same type of block diagram. This is very important. You have to mug up this particular block diagram. All right, we are going to the next one, the pin configuration. This is also very important. That means what pins are for what functions, where is the supply, and how, where is the ground pins, and what are the other pins, that is P1, P2, P3, P0, or for what pins we are using it. That is, you have to understand. That is for 8051, 8031, 89420. On the other side, you can see on the left-hand side, I have taken 8085A also. That means what I'm trying to tell you is pin diagram you should all understand properly. All right. So next is data conversion. There's a very important topic, that is data conversion, ADC and DAC. Data conversion, ADC and DAC, that is nothing. That is, what is it exactly? What does it do? What does it do? ADC converts analog voltage to digital codes, okay, via sampling and equalization. And vice versa is for DAC. That is, again, it is reverse. So ADC application, where do we use it? Sensors, microphone, medical images. That is, sensor data is converted into digital data. Whereas DAC application, motor control, audio output, MP3 player, display, drivers. That is exactly the reverse, right? That is exactly the reverse of ADC. That is, DAC is nothing but digital to analog conversion. For motor, driving a motor, we use this for audio output because the speaker, the sound is analog, but the audio can be in digital. We have to change this. Like MP3 is for video, right? You can see we have digital video, and when we see on the screen, it will be analog. Now, ADC and DAC, some popular IC you can see on this on your screen, that is on the left-hand side, ADC 0804, ADS 1115, whereas DAC 0808, MCP 4725. Here I have given a simple diagram, that is analog, how it is converted to digital and digital to analog. That is 1001, that is digital and analog signal. You can see how it is converted. Okay, so this part is also very important. Next is, we have also should study about real-time clock, that is called as RTC timers. A real-time clock, RTC, is a specialized battery-packed integrated circuit that keeps accurate human readable time, seconds to year time, and naturally when the times is there, days, seconds, and year, everything is counted into time. So time, basically it's a time, it's a clock. Even when the main system is off, unlike CPU-based timer, it used a low-power quartz crystal oscillator to track timer. It is used for IoT and other application, that is home appliances application in embedded system. So I've given some pictures over here, that is RTC 3231 and RTC 1307. These are the two crystal oscillator, or we call it as a RTC, real-time clock. We call this thing. We use it for our projects and for getting the computer. Where is the application? What is the application? Embedded system and IoT, industrial equipments, computing. Of course, the computer also maintains the time. So you have the same system inside your computer board also, consumer electronics. So these are the application of your real-time clock, that is RTC and timer. Then we'll study more about displays, right? Displays. So before this, displays are electronic device or surface that visually present information, text, images, and video from computer, smartphone, or other devices common technology include LCD, OLED, that is organic light emitting diode. LCD stands for liquid crystal display, right? LCD, what is the difference between OLED and LCD? The LCD uses a backlight, that is the light there will be behind, LEDs will be there to give you the light, while OLED have self-emissive pixel, that is it will glow by itself, right? So I've given some varieties of the displays, that is CRT. We used to have a old type of a television, that is cathode ray tube. Then you have LED, then electroluminous display, ELD we call it as, then electro paper, E-link display paper, then PDP, LCD, DLP, OLED. These are the different type of displays. So on the right hand side, you can see different displays are there with different modules will be there, different colors for colors. What we use on our mobile phone, those are also displays, whether those are color displays, okay, OLED or LCD displays. We have, starting with, when we study, you should study with a 7-segment display, which is given on the corner here. This is a 7-segment display. This is OLED display. This was small OLED display, what we use for a project. This is OLED display. LEDs, signboards or bigger, this thing, which is made only with the pure LED. These are the television display, that is the complete panel, we call it as. And this is smartphone display. And this display also, that is 2 by 16, 2 multiplied by 16, 16 cross 2 LCD display, we call it as. So this about the display, different pins and different this thing, that is to generate the characters, different pins are stipulated. This also will work with 5 volts, 3.3 volts. Please remember this, all this display. It's a big subject, but you should start to understand what is display basically. So interfacing of display is also very important. So suppose you want to drive a 7-segment display. As you can see here on your screen, this is 7-segment display. There are 2 types of 7-segment display. That is, one is common anode and another one is common cathode. So the switching, the supply, one is given the common to the VCC and the other it is given through the ground. As soon as you give the switching through a resistor, that is 220 ohm resistor, the LED which is present in the 7-segment, it will glow and it will make a form, a digit or a number. Whereas LCD screen, this LCD, you have 16 cross 2, you have this approximately 6 to 7 character generators. That is 7, you have 2 rows in this, 2 row and 16 characters. Okay, both are. So this is a little yellowish type, this is bluish type, a little bit of variety of it. A small circuit I have given it here, that is using an Arduino board. How you are going to connect the display. This project you can do it by yourself when you study about the Arduino. The first thing, how to give connection to an LCD, that is 16 cross 2 display. It is given in this. All right. So this is about display interfacing, that is 7-segment and the LCD. Then we should also study very important part which is related to display, or which comes next to the display, is keyboard matrix, that is 4 by 4. That is 4 rows and columns, we call it as. So all the numbers and characters are covered in there, as you can see here on the bottom side. This is the main display or other type of display which can be there. So internal structure, there are buttons, switches, and it's just connected through rows and columns like through your resistance, and this thing is given. So 4 into 4 matrix membranes, keypad, parallax A, that is 4 into 4 matrix keypad, is an input device with 16 buttons. Please remember 4 into 4, it is 16, 0 to 9, A to D, and star and hash, arranged in 4 rows and 4 columns. 4 rows and 4 columns. Required only 8 microcontroller pins. Right, is only 8 microcontroller. The 16 switches will be working with 8 microcontroller. That is the matrix circuit, we call it. Keypad offer, right? Okay, that's why we call it as this thing. All keypads, different type of boards, this work on the matrix circuit. So keypad often uses tactile or membrane switches featuring a 2.54 pin header for easy interfacing with Arduino PIC or 805. So these are the Arduino is a microcontroller, PIC board. PIC is a microcontroller, 8051. Already we have studied about. So one more thing I would like to concentrate, or I would like to discuss about this thing, that relay driver switching. For designing electronic projects, please remember the load are connected, switched on or off using microcontroller blocks. That is, you can see here, there is a microcontroller. That is, I have used a PCF8574P. This is the microcontroller. So directly, the microcontroller will not drive the relay. That means the electromechanical switches, so that you can operate different type of switches and relays. So what we do in between, we use a part called relay driver, right? This is ULN2803. So you can use a relay driver circuit, or you can use this IC or chip, that is ULN2003, CS1107, MAX 4896, FAN 3240, and A2550, and so on. So this is also one of the important part. That's why I have taken, or I have put it in my subject. All right. Next topic is about serial communication. So what is serial communication? In a microprocessor, or microcontroller technology. Serial communication is defined as a type of data communication method. It's a type of a data communication method in which data is transferred bit by bit, that is one bit at a time. Hence, serial communication is sequential method for data transmission at a given particular time. Okay, sorry, not the given particular time. It is given on what do you call it? Over a communication channel. Any communication channel, that can be 2 or 3 different communication channels can be there. So on the you can see here transmitter, receiver, and serial communication. How does it take place? That is 1 and 0s. How it is sent. The same way the clock pulse is also sent. Okay. So we'll come to the next slide. Next slide. Again, one more important topic, that is pulse width modulation. That is we call it PWM. So what is pulse width modulation? Pulse width modulation, PWM, is a digital technology that uses the amount of power delivered to the device that can be changed. Okay, it's a digital technology which can deliver the power to be changed. It generates analog signal by using a digital source. Right, digital source is used. What signals are analog? A PWM signal is basically square wave. You can see here, it's a square wave which is switched between on and off state. Okay, on and off. Suppose this is on state and this is off state. Where it is used: DC motor speed controls, LED brightness control, duty cycle calculation. There, this plays an important role. That is your PWM controls. Okay, right. Now we come to the main part, that is the MCQ part. So I've given few of the question for your preparation. That is, what is the size of a data bus in 8051 microcontroller? It is 8-bit. The correct answer is 8-bit. Question number 2, how many IO port does 8255 PPI have? It has 3 ports. That other diagram which we discussed before, you can just go through the diagram and you can check it out. Third question is, which IC is commonly used for RS-232 voltage conversion? It is MAX 232, right? So this is the third question. Fourth question, HD44780 controller is used for LCD interfacing. We also call it as a LCD driver. Correct. Question number 5, in a 4x4 keyboard matrix, how many IO pins are required? 8 bits. Okay, how 8 is. So that also we have just now seen. Question number 6 is ADC0804 is an 8-bit ADC. So the chip number or IC number, you have to remember well so that you can immediately give the answers. Okay, so 8-bit is the correct answer. Question number 7, PWM stands for pulse width modulation. Very simple. Question number 8 is DS1307 is primarily used as RTC, that we have just now discussed, that it is an RTC module. Next question is question number 9. How many timer counters does 8051 have? It has 2 counters. So I have given 9 questions in here in this particular so that you can prepare and you can study. These are only very basic things for you to study or to prepare for your exam. It will have, I will come next week with the second part where we'll discuss about the same topic with a different subject and other things. And I will give you a few more questions over there. I hope you like this, and please share with your friends who are preparing for the examination. And thank you for watching. See you next week.